All right, you guys. So we are coming back to our last sort of topic on exponents. Now, negative exponents, I don't consider them to be a rule. I just consider them to be something we need to know how to manage. Okay. And if you look here at the screen on the problem on the right, which we're going to get to in a moment, you can see my problem has in it negative exponents, and I need to know how to handle those. Okay. Now, here's how it works. Okay. If you have x to the negative a, that is equal to 1 over x to the a. So what happened was is I created a fraction, okay, and I moved this statement here to the denominator and I made it a positive exponent, okay? Some of you might be looking at it and thinking to yourself, well, she flipped it over. Yeah, if I make this a fraction, I did flip it over, but something happened when I flipped. I changed my negative exponent to a positive exponent. All right, same thing. If I have 1 over x to the negative a, yes, in essence, I'm going to flip it over. And when I flip it over, I now have x to the a. And again, I'm writing it in a different color because it's not required, over 1. Remember, if I have a denominator of 1, I'm not required to write it. Okay? If I have a numerator, though, I am required to write it. Okay? So that's the rule, so to speak, or what's going to happen. I use an approach that's called stay. Oh my gosh, just spelled that wrong. Stay or go. And so what I ask you is I ask you as I'm going through the problem, does it stay or does it go? All right. So let's look at this example. X to the negative 4, x squared, y to the negative 8 over y to the third. Okay, so if we were face to face, what I would do is I'd ask you all a question and I would not stop until I got the same response from all of you guys. All right, here's how it works. Okay, if the exponent is positive, it will stay. All right, so if the exponent is positive, it will stay. If the exponent is negative, it will go. All right, and you might be asking yourself, where is it going? Okay, it's going to the other side. And when I mean the other side, it's going to the bottom. And if it's at the bottom, it's going to the top. Okay, all right, so I always write down my fraction bar first. Okay, all right, so now I start here and I don't do anything. I don't do anything else in the problem. You might have other teachers who will start doing stuff, mark it, no. We're going to start the problem this way. X to the negative 4, does it stay? Does it go? Well, it's negative, so it goes. It goes to the bottom. And look how I wrote it. I wrote it with a positive exponent because when it goes, it changes. All right, now I go to the next one. X squared. Does it stay? Does it go? It stays. So I write it where it stays, on the top. Y to the negative 8. Does it stay? Does it go? It goes to the bottom. Okay, so there's my numerator. Now I go to my denominator. Does it stay? Does it go? It stays. It's a positive exponent. I don't care that it's in the denominator. It's a positive exponent. It stays. There it is. Okay. So now what I've done is I have taken my problem and now I have all positive exponents. Okay, so what we're now going to do is we're going to take some of the problems we learned earlier this week and we're going to now combine those into this problem that we're left with. Okay, don't panic. All right, so I have x squared and I have x to the fourth. One's in the numerator, one's in the denominator. Okay, that's the property that says I'm supposed to subtract. So if you remember, I said, okay, I'm going to circle the larger exponent. So the larger exponent is 4 and it's on the bottom. So that means I'm going to do 4 minus 2. All right, so 4 minus 2 is x squared. I wrote it there. Okay, now if you're thinking, okay, well, how do I know I'm done? Well, if you've done 4 minus 2, I've got a pencil. Okay, I can cross those out because I'm done. I don't have to look at those anymore. Okay. All right, now I got these two little y's here, right here. I got y to the eighth and I got y to the third, and I got to do something with them. Okay. All right. So if you remember all the way back to the very first exponent rule, when the problem is written like this, I'm going to add my exponents. So let me add those up. Okay, and I'll move that to the next step. So 8 plus 3 is 11. So y to the 11th. Okay. All right. Now, we cannot leave this numerator blank. So we put a 1 in it. Okay. And then we look over here. Now, we've got some really good problems or answer choices that are a distraction. Okay. We've got the correct one. So I'm going to select that and I've got that. All right, let me talk about some of the distractors. Okay, this one right here is the one I would anticipate people picking if they've applied the property correctly in terms of they did the 4 minus 2 right, they did the 8 plus 3 right, but they forgot to write it all in the denominator. Okay, that's why it's really important to write that fraction bar in each step so you know where to write things. Okay, so that's why this one's not a good one. All right, this one, okay, you did really good. But what happened was is that for some reason, instead of subtracting the exponents here, okay, if you can see my mouse, I've got it right here on x to the 6. You've got here over here on my hand. Okay, instead of doing 4 minus 2, you did 4 plus 2. Okay, so that's what happened there. Okay, you added instead of subtracting. Okay, and then here, yeah, same thing. You added, but then you also lost track of your fraction. Okay? All right, and then if we hit submit, yes. Okay. Now you can see, oh, look at that. Look at that. So me and Delta Math, Mr. I can't even pronounce his name. We'll just call him Mr. Delta Math. Okay. Him and I think the same way. Okay. All right. And so I'm really happy with that. All right, let's try another one. New problem. Let's see if I like it. Yeah, I like that one just fine. All right. So x to the negative 8 times x to the 8 over x to the fourth. Okay? All right. So stay or go. All of these problems start with do I stay, do I go? Okay? All right. So x to the negative 8. There's my fraction bar. It goes. So it's going to go to the bottom, and it's going to become x to the 8th. All right, so that one's gone. So if you want to take your pencil, say, okay, I've taken care of that one. All right, x to the 8th stays. X to the 4th stays. And when I'm saying stay, it stays in the numerator, and then x to the 4th, it stays in the denominator. Okay? All right, now you got a couple of different things you can do here, but if you remember, I told you last week that if you had the same variable and the same exponent, you could eliminate them. We have that. We have the same variable, we have the same exponent. So this eliminates, which means I'm left with x to the 4th on the bottom. All right, and I have to fill in that numerator with a 1. All right, so we look over here. I got it. Okay, submit my answer. Yes. There you go. Okay, you can see here with Delta Math, and this is fine too. He went ahead and added 8 plus 4 and got 12, and so he had an extra step. Okay, so we actually were able to do the problem in one less step. All right, one more. So x to the negative 8, y to the negative 6, y to the 5th over x to the negative 3. Okay, stay or go, stay or go. X to the negative 8 goes. Went to the bottom. Y to the negative 6 goes. Move it to the bottom. Y to the 5th stays. Now, here's a little tip. Organize your work. Put your Y's over your Y's. All right? X to the negative 3. It goes. It goes to the top, and look where I'm going to put it, because I can put it in any order that I'd like because I'm multiplying. All right, so now this is good to go. So I'm just going to, not even going to look at the y's at the moment. Okay, I've got x to the third over x to the 8th, so that's going to be a subtraction. That's what exponent rule I use. And my larger exponent here is on the bottom. Same thing with y's. My larger exponent is on the bottom. So that means I'm going to do 8 minus 3. So I have x to the 5th. And then on the y's, I have 6 minus 5, which is 1. So I just write y. I don't have to write y to the 1. You can if it helps. And then I put a 1 in the numerator. Okay? So each step maintain that fraction bar. Okay? So if I look over here, that's this answer here. Yes. And we're done. Okay? All right. So if you need more examples, let me know. If you have any questions, let me know. If you've got questions about a specific problem, take a picture of it and send it to me and remind. That's probably the easiest one. That way I can work it out on a piece of paper, take a picture, and send it back to you. All right, good luck, you guys.